Alright, today we are going to be continuing with tutorial 4 on our Python programming tutorial for 2019. So remember to subscribe by clicking on the subscribe button below this video now so that you get notified when I make new lessons, and also you kind of motivate me to continue making these lessons free for you. And also feel free to let me know if you have any challenges, if you have some path that is difficult for you to follow, just put it in the comment box, let me know what challenge you have and I'm going to respond to you immediately. So today we are going to be covering operators in Python, arithmetic operators, operator precedence, comparison operators, and assignment operators. In the case of operator precedence, I'm going to write this because this is something that all of us know. So I think it's called brackets, and O is for D is for division, multiplication, addition, and subtraction. O is for what? Some maybe exponentiation, but I can't remember. So let's just use it to see how it goes. Let's start with arithmetic operators. So let's say A is equal to, let's use what we learned before, AB, C is equal to 10. So there's no simplification coming here. So we have 10, 20, and 30. Alright, so this means that A is equal to 10, B is equal to 20, and C is equal to 30. So we can just print A plus B, let's use multiplication, times C. So what is going to come out? We have 10 plus 20, which is what? 30. 30 times 30, 900. Let's see. So we got it wrong. Why? The reason is because multiplication have higher precedence. So what actually happens? We have B times C, 600 plus A, 10. So let's do something else. Let's try to use division. Let's see. So what do we expect? B over C, 20 over 30 is what? 2 over 3. That should be giving us 0.6 times 10. So we have 1.667 or something. So we have 10.6667. So basically it works in the same way as you know. So multiplication, division have higher precedence over addition and subtraction. So let's try to use this modulus operator. So let's see. So this operator returns the remainder after a division is carried out. So let's take, for instance, we say something like 10 divided by 3. The answer is supposed to be 3.333, but now if we use this operator, we have 10 divided by 3 is 3, remainder 1, and it's going to give us 1. So it gives us only the remainder. And the same way, if we say 8 over 3 is actually 2, remainder 2, and so the answer is going to be 2. Another operator is the exponentiation operator. So this is actually, you use it to raise a number to a power. So you have 2, 3, 3, so it means 2 to the power of 3. So 2 times 2 times 2, I'm going to write it out, 2 times 2 times 2. So that is exactly what it means. So the number inside can be anything. It can also be 10. 10 to the power of 3 means 1000. So that is how exponentiation works. So let's look at the next one. We have floor division. So floor division means it actually truncates and throws away the decimal point after the division. So if we have 10 over 3, the normal division, 10 over 3 is 3.3, but 10 floor divide 3, what is it going to give us? It's going to give us 3, right? Good. So that is basically how floor division works. Now I want to teach you about something important. When it's a negative number, is actually a little different. So we have 10 divided by 3. Normally we have 3.333. When it's not negative, we have 3. But when it's negative, it's going to be false. So if it's negative, you have a number that takes it to the more negative number. So if we have this, we expect to have -4, right? Good. So that is floor division. It throws away the decimal points, but if it's negative, it actually kind of, let's say, rounds it up to the higher number and you add a negative sign. Let's look at another thing, operator precedence in Python. We've discussed that. Let's now look at comparison operators in Python. Comparison operators actually returns either true or false on an operation. So if we have D is equal to A, so equal sign, A is equal to B. So this is actually legitimate. So I'm going to print out D. So what do we expect to see? A is equal to B. It's asking a question that says, is A is equal to B? Is A equal to B? Because we are trying to compare A and B. In this case, the answer is no, and it's going to print false. So in the same way, we can say, is A not equal to B? So we have this to be, is A not equal to B? The answer is true. So it's going to print out true. Is A not equal to B? And that is D is going to hold the value of true. And the same thing goes for the greater and less than. I think it's the same thing as not. So, or maybe it's not part of Python. I can't remember. So let's try to use, is A greater than B? Well, the answer is false. So A is not greater than B, and so on. So this is greater than or equal to, less than or equal to. You can try it out by yourself. Let's now look at the assignment operators. Normally, in traditional programming, we have something like D is equal to D, let's say A, is equal to A plus, let's say we add 10 to it. So this means A is equal to 10 plus 10. So the answer is going to be A will become 20. Right, good. But now Python allows us to write this in just one single line that says A. Now what you are going to do, let me show you how to convert this to this. So take out one of the A's and just swap the positions of the plus and the equal sign. So this A plus equal to 10 is the same as the same thing we wrote before. A is equal to A plus 10. So that is exactly the same thing. So this is more like a short form of writing it. Alright, so you can also say D is equal to A is equal to 10. So let's see if we can put the plus sign here, so we can have it changed in two ways. So let's try it on the other side. So while you can do it once, you can do it 2 times. But this is actually very, very correct. So if we use D, we have D is equal to A is equal to 10. All of them becomes 10. Alright, so the same thing goes with multiplication and division. So if you have A is equal to A times 10, so it's the same thing, A times equal to 10. So what it's going to give us is going to give us the value of A to be 100. So let's try to see. I'm going to run it and it gives us 8,000, right? A is equal to, okay, we already do it 2 times. We already do it here. A is equal to 8 times 10, 100, and we have 100 times 10. Gives us also 100. So I'm going to give you an assignment. Try for these 3. Write them in one single line and then write it write them in expanded form and then write it in short form. For instance, you have something like A is equal to A modulus 10, and then also write it in the other way. Alright, let's now get to the next one, logical operators. So let's start by saying something we've done before. D is equal to A equal to B, right? So what we are saying here is A is equal to B? The answer is yes or no, true or false. So that true or false is going to be stored in D. So now we can use the not operator because this is where we are. Okay, let's write the second thing. D is equal to, let's say C, let's say B, not equal to D, right? So here we have, let's say B is not equal to D, that's gonna work. So let's say B is not equal to 20. Alright, so D is equal to holding the result of comparing A and B. So D is going to hold a value of of false, right? So let's just see, D is going to hold a value of false, and then E is going to hold a value of true. The reason is because we are saying B is not equal to 20. The answer is true, so it's going to be true. B is not equal to 20. So E is equal to B not equal to 20. Actually, B is equal to 20. So when we say B not equal to 20, so it's false because B is equal to 20. So now we have false, false. So if we use a not operator on D, so if we say not D, it's going to change it to true. So not actually changes a false to true, and then not, yeah, changes a false to true. So let's look at another operator, OR. So we have D and E. So we already know what D and E is. D is equal to false, E is equal to false as well. So when we say A, or when we say D or E, is going to return true if either of the two of them is true. So it's false, but if I use not D here, it's going to return true because not D, of course, is true because D is false, therefore not D is going to be true. So if I use the AND operator is going to return true if only two of them are true. So this is giving us false because E is false. So if I put not E here, so both of them are going to be true, and so it returns true. So now here is the thing I want you to know. The first items we've discussed, these first 5, try to take some time to go through them. Now, a little bit, the one that will be a bit tasking will be the bitwise operator, but it's really very easy. I'm going to show you an easy way to do it. Now we have the first item is a bitwise AND, bitwise OR, bitwise XOR, bitwise NOT, logical shift left, and logical shift right. What are all these? They operate on binary numbers. So before we continue, let me show you how to assign a binary number in Python. So if you have A is equal to, let's say a binary number is 0011 and 1100. So for instance, we want to assign A is equal to 0011 1100. So it's going to give us an error because to specify a binary number, you need to tell the compiler that this is a binary number and not just a number. So what you do is to put 0B in front of it. So just say 0B. So at this point, the compiler understands that this is a binary number, and B is equal to the same way I use 00001101 and I'm going to use 0B in front. If it's octal, you can use 0O or 0x or hexadecimal, right? So, but now we are talking about binary numbers here. All right. So we've specified a binary number 0B. So this 0B is actually not part of the numbers. So let me just show you a bit of how to manipulate decimal numbers. Basically, I'm going to recap binary numbers for you in the easiest possible way that you need to know as a programmer. So let me take my writing pad, and I'm going to teach you how to convert to binary very easily. So let's start by writing this, and this is something you need to know. 1, 2, 4. Basically, you are taking powers of 2, 16, 32. Now, if you are given a number like 1101, convert it to binary. What do? You simply start 1011, right? 1101, and you add together 8 plus 4. In 2 we have 0, so we don't add 2, plus 1. So 8 plus 4 is 12, 12 plus 1 is 13. So we have 13, right? Good. So if you are given a number like 1000, convert to decimal. So you have 1000, convert to decimal. You have 8 plus 0 plus 0 plus 0 because we don't have anything here, here, and here. And it's going to give us what? It's going to give us 8. Now the same principles goes if you have 0, 0, 1, 1. How do you convert these? You have 0, 0, 1, 1, and you have 2 plus 1 gives us 3. So before we go back to Python, let me just tell you a little about shift. So when we have 0, 0, 0, 0, and we use this operator, what is this operator? This operator is logical shift right. Let me just use this. So logical shift right shifts the 2 bits, kind of shifts this to the right like this. 1, 1, 0, 0, right? And then you are shifting in this way. And then you make it up to 0, 0, right? So we'll go back to Python to see how it works. I'm going to explain it more in Python. So I'm going to actually stop here, and when we get back to Python, we continue with binary operators. I'd like to thank you for viewing, and also like to remind you to subscribe by clicking on the subscribe button if you've not actually done so. More especially, I would like to thank you for the effort you put to learn, because it's actually very good that we spend our time as programmers to learn something new.